Welcome! Professor Ripley here to show you how to accurately calculate mean and standard deviation in less than 10 minutes. Make sure you have your scientific calculator and some paper and pencil ready, because this is a follow along at home active learning tutorial. If you have access to Google Sheets or Excel, have that ready as well. First of all, why do we calculate both mean and standard deviation? The mean, shown with the red line, tells us where the arithmetic center of the data set is, or where it is located along the x-axis. Two sets of data can have the same mean, but very different distribution shapes. The width of the distribution, measured by standard deviation, shown with the blue line, tells us how different the individuals we measured are from one another. Okay, here's the formula for the arithmetic mean, or average. We call the mean x bar, which equals 1 over little n times the sum from 1 to n of the observations, little x sub I. You probably already know that it is calculated by summing up the observations and dividing by the sample size. Let's look at how this equation tells us that. Here it tells us that we should take each observation one at a time and sum them up. The little I corresponds to each observation in the data set, and we divide by little n the sample size. For this sample data set of the length of sardines, a small fish, little n equals 7. To finish calculating the mean, sum up the data and divide by 7. Here's what it looks like, both in my tabular style and also how you might write it out by hand on paper. Pause to make sure you get the same number when you use your own calculator. Now the standard deviation, also called the root mean square error. We call the standard deviation little s, which equals the square root of 1 over little n minus 1 times the sum of the square difference between x sub I and x bar. There's a lot going on here. Let's unpack it. Notice that in the take the mean part, we now have little n minus 1 instead of n. Once we have calculated the mean, we lose what is called a degree of freedom. That indicates we now have one less piece of independent information than we did before. Ask me about that later if you want to know more. The other part here are the deviations, where we subtract the mean from each observation, which tells us how far they are from the mean. But if we try to add those up, some will be positive and some will be negative, so they will sum to 0. That's why we square them to make them all positive. Then we unsquare the whole quantity at the end to restore it to the units our data are in. Let's practice on the same data set. We need to know little n and x bar to start. Then we begin by taking 6.3 minus 8.6 and square it. There ends up being a lot to write down to work out this equation. If we wrote it all out, it would look like this. It's tempting to write it like this, but there are a lot of places you can make mistakes, especially when you get to the end. You might forget to divide by 6 or take the square root. Here's an alternate method. Set up a data table on your paper like this, with room for all the steps. First, find the deviations, then square them. Once you sum them up, it's called the sum of the squared deviations. Then multiply times 1 divided by n minus 1. Then take the square root. The answer you write down will probably have too many digits, So your final step is rounding off to match the digits in your data set. Here's what we get for these data. Pause to make sure you get the same numbers with your calculator. Also, if you have mean and standard deviation functions on your calculator, go ahead and try them to make sure they come out with the same answer and you are using them correctly. However, you may be asked to show all your work on an exam, so be prepared to do so. This is a smart practice anyway, because you will get partial credit if you set the problem up correctly, but make a small calculation error and miss the final answer. In practice, though, we will never calculate these summary statistics by hand. This is Excel, but it works just the same in Google Sheets. In a blank cell, type the equal sign, then start typing average. The function for average will pop up. Double-click, then highlight the cells with your data. Then put in a right parenthesis and click Enter. For standard deviation, do the same thing using the function stdev.s. Voila! So why, if this is so easy, Professor, are you making us calculate by hand? Well, first of all, to increase your comfort and fluency deciphering and using equations. They will get more complicated as we go, so it's nice to start on some relatively easy ones. Second, to practice making each step carefully with attention to detail. Third, to check that you are using your calculator correctly. And finally, to build a habit to work out problems step by step so that you are more likely to do the work correctly, and if not, you can find where you made the error easily and fix it. You will get better and better at all these skills throughout the semester. Finally, seeing your work shows me what you understand and where you are still confused. We will end with some practice problems for you to work out to make sure you're getting it. Pause to work these out and then look at the next slide to check your work. Okay, how did you do? Practice one more problem from the textbook without looking at these slides to make sure that just using the equation, you know what to do. Congratulations, you got it. Way to go.